Okay, this is where teamwork comes in. One, I'm going to talk kind of fast and write fast, and I'll upload this PDF of all these answers to Google Plus so you can have access to it. But what I want to do mainly... Yeah, hi, Ethan. This is Ethan. I'm home with the sick boy, and he's playing with my calculator. It's my graphing calculator. And anyway, so here's a quick run through. If you need to pause, rewind, you just do it. It's kind of at your leisure. That's the best part about these videos. Okay, the first thing, this 2.3 review. If you don't have it out already, get it out and give yourself time to work on it. I don't know. We got 13 problems there. If you had 10 minutes, that'd give you a good start. Maybe 5. But tackle those, and then when you're ready, hit play on this, and I'll go through the rest of them. Kind of pause and start as needed. So here goes. If I'm going to tackle number 1, the first thing I want to do to graph this is notice it's to the 4th power. So it has that even end behavior, so 2 arms up or 2 arms down. And in this case, it's negative 2 arms down. See how it's a negative something to the 4th? So I know the 2 arms go down. And then there's the shifts. There's a left 2, stretched, flipped over, and it's vertically stretched by 2, and then it's down 1. I don't know if you can see all those components. So and then the last thing I want to do, so it's facing down, left 2, down 1 because of the plus 2 and minus 1. And then the other thing I always do is put 0 in for x to get an intercept. You get out negative 33, so it gives you a sense of where it crosses the y-axis. Okay, next one, same idea. I got to shift right 2, up 1. You see the minus 2 inside and the plus 1 outside. And it's also stretched vertically by 3. It's a 5th power, an odd end behavior function, so I got an arm down and an arm up. And so I got the idea of what it looks like, and then I put 0 in for x and get an intercept of about negative 95, I think. Could be off on my arithmetic there. So I got that odd behavior looking kind of graph, positive odd, and an intercept to give me a general sketch. Moving on. Okay, so let's do the end behavior in limit notation. And the way we do end behavior is you look at 2 things, the highest degree and the sign of the leading coefficient. This is negative, so it's facing down, even, so it's 2 arms down. So the limit as x goes to positive infinity to the right, it's going down to negative infinity, and limit as x goes to negative infinity, also going to negative infinity. Number 4 is positive odd, 2, and the highest degree is 3, leading coefficient 2. So we're going to do limit, if you go to the right, y goes to infinity. If you go to the left, y goes to negative infinity. Okay, and we have a negative odd in number 5. So as you go to the right, x goes to infinity, y goes to negative infinity, and to the left, y goes to positive infinity. And down below, again, you can look at Google Plus, grab the PDF of this, might help as well. 6 is positive even. So both go, as you go to the right and to the left, you both go to infinity. And then number 7, with the degree 2 of each of those factors, you know you're going to get negative, and then a negative out front, negative x to the 4th, blah, 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 whatever it. That means it's 2 arms down, even end behavior. As x goes to the right, positive infinity, y goes to negative infinity. As x goes to the left, or negative infinity, y also goes to negative infinity. So, and finally, this number 8, look at that degree 4 out there and a degree 1 in the other factor. So all together, and if you multiply the 2x and 3x, you'd get 6x to the 5th plus, a whole lot of other polynomial stuff. But all we care about is the leading coefficient and the highest degree. So it's positive odd. So as you go to the right, limit as x goes to infinity, y goes to infinity, and limit as x goes to negative infinity, y goes to negative infinity. So moving on, go for the zeros. In number 9, the zeros are the easy part. You got negative 1, 2, and negative 2. And the multiplicity is what's the degree of that factor. So 1, 2, and 3, respectively, because of their degrees. And then you're supposed to describe crosses or touches, and I like to say bounce. I'm writing here just bounce, and that means if I don't write bounce, it passes through. So there's a pass through at 1, pass through at negative 2, a bounce at positive 2. Number 10, 0 is a factor whenever power of x is pulled out. 3 is a factor. Multiplicity 4 for the 0, multiplicity 3 for the inside function there, or inside factor. There's a bounce wherever there's an even multiplicity, even degree for your factor. So there's a bounce at x equals 0. And then finally, number 11 requires you to factor out first a greatest common factor. So you want to get out x squared. And then once you do, you have a quadratic that factors to x minus 4 times x plus 1. And then we do the same thing we've been doing. We got a root at 0, we got 1 at 4, and negative 1. The multiplicities are 2, 1, and 1 respectively. And the bounce is at the even degreed one, which is at
It's
0.
doing.
Yeah, what's fine? Did it go off? Hang on, guys, just a second. We got a calculator that turned off. There you go. Is that better?
Yep.
Thanks. And then, you can't smell that, but whew, I think we have a diaper change coming. All right, on we go. Sorry about that. Other sheets. You got this other half sheet. Want to grab one of those if you haven't already. Give yourself, 5 minutes to try and do some synthetic division, long division practice. Okay, so here's the starting one. Use long division. All right, I'm going to work through it. If you hit pause, great. If you're just watching it, sorry it's so fast. Just pause and rewind as needed. We're going to do x minus 1 into 3x squared minus 6x plus 7. X goes into 3x squared 3x times. And then I multiplied through 3x times x minus 1. And that's what I've written here below. Now we're going to subtract. I like to add the opposite. So I change the signs of those things and just add. And I get negative 3x, bring down the 7. X goes into negative 3x. Negative 3 times. Multiply the negative 3 out. And then change signs and add down. Okay, so I get 3x minus 3 plus 4, the remainder, over x minus 1, the divisor. And if we do synthetic division, we're going to use that 1, the root, not the factor. So it's x minus 1 is the factor and 1 is the root. So we put 1 in the box, bring the 3 down. 1 times 3 is 3. Add down, get negative 3. 1 times negative 3, negative 3. 7 and negative 3 gives us a remainder of 4, same as we got before. So this, in fact, is the same thing. So same result, just wanting to justify that. 3 is determine if it's a factor using synthetic division. It's a factor if the remainder is 0. If it's not 0, then it's not a factor. I went through it in synthetic division. You can check it against mine. If you get a remainder, which we did, it's not a factor. And then the part B here, use remainder factor theorem. That's if you take the root, or the proposed root, the x minus 3, so I'm going to put 3 into the original function. What you get out is the remainder. So if it were a factor, you'd get out 0. But if not, then you get out the remainder. Kind of tells you how far off this number is from being a root. So that's the end of that. And the last one here, it says how many root zeros are there. I'm going to leave that one for you guys and do the rational root theorem. And then you'll have a quiz that might have that included. But I just want to see where you're at with that. And then I'll check in with you guys tomorrow. You can retake your glove? We'll find it in just a second, buddy. All right, Ethan, you want to say bye to the class?
Bye.
See you later. Okay, see you guys.